Assalamu alaikum. Myself Ansari Safiya from Department of Physics, J.A.T Arts, Science and Commerce College for Women, Malegaon. Today we have to study work done during an isothermal chain. A thermodynamic process that takes place at a constant temperature is called isothermal process. Now we have to obtain work done during an isothermal chain. Consider 1 mole of a perfect gas contained in a cylinder having perfectly non-conducting walls and a perfectly conducting bottom fitted with a movable piston. Let V be the volume, P the pressure and T the temperature of gas. Now the cylinder is placed on a source of heat at the same temperature T. If the piston is allowed to move slowly outwards, the gas expands, does some work, and due to it the temperature tends to fall. Heat is therefore absorbed from the source at the constant temperature T, and thus the temperature of the gas is kept same. Now the expansion is isothermal. If A is the area of cross section of the piston and it moves through a small distance dx, so that change in volume is dV, then the small amount of work done by the gas is given by dW is equal to force into displacement. Force F is equal to PA into dx, but AdX is equal to dV. Therefore, the work done dW is equal to PdV. Now, the relation between pressure and volume under isothermal condition can be represented graphically by the isothermal curve AB as shown in figure. The work done for a small change in volume dV corresponding to the pressure P is given by the area of the strip ABDC and is equal to PdV. Now for 1 mole of a perfect gas, PV is equal to RT or P is equal to RT divided by V. Hence work done dW is equal to PdV is equal to RT divided by V into dV by substituting the value of P. Therefore, the total work done when the gas expands isothermally from a volume V1 to V2 is given by the area ABDC included between the isothermal AB and ordinates AC and BD corresponding to the volumes V1 and V2. Now integrating above equation, we get total work done W is equal to integration dW equal to integration V1 to V2 RT divided by V into dV. During an isothermal process, the temperature of the gas remains constant. Therefore, work done W is equal to RT integration from V1 to V2 dV by V is equal to RT. Now integration 1 by V, that is log to the base E V from V1 to V2 equal to RT log V2 minus log V1 equal to RT log V2 divided by V1 equal to 2.303 RT log to the base 10 V2 divided by V1. This is the expression for the work done during an isothermal process. for 1 mole of a perfect gas when its volume changes from V1 to V2 at a constant temperature T. Also, for an isothermal change, P1 V1 is equal to P2 V2 or V2 by V1 is equal to P1 by P2. Substituting this value in above equation, then we get work done W is equal to 2.303 RT log to the base 10 P1 by P2. Now this is the expression for the work done during an isothermal process for 1 mole of a perfect gas when its pressure changes from P1 to P2 at a constant temperature T. Now thank you.